Hi everybody, I'm Mark Waite. I maintain the Git plugin, and this is some ideas, concepts around dealing with things that we may have made mistakes in. For instance, sometimes you discover that people are checking in large binaries into your Git repository, and those large binaries live forever. And that Git repository gets larger and larger and larger. As you deal with large repositories, they have unique problems that you have to deal with. And you made a mistake. It really isn't healthy to have large repositories, but you got to find a way to deal with it. So there are some key concepts that you can use to frame your efforts to decide how to help yourself best to live with a large Git repository. Some of the things that you can do can help you in reducing the load on your remote, on the central repository. So there are things that can help there. Some of the things you can do can help you on the Jenkins master, where it has certain things that it does, like polling for you or caching repos for pipeline. There are other things you can do that will help you on Jenkins agents, where the pipeline cache is, where you've got the local repository copy, and where you've got a workspace. Each of those three areas have different things which can help them, and those different things may be applied in different ways in your environment. So it'll help you to understand which things apply where. So first up, what can we do to reduce the load on that central server, the Git remote repository? The remote repository has all the history in it, but it only has to send history that's requested. So one of the things we can do is find ways to ask for less history. The Git repository includes all the large files, but we can find ways to only ask for a subset of the large files. So some of the techniques available there is we can use a reference repository. What that does is that provides a local cache that can ease the load on the central repository. We can use a narrow Refspec. A Refspec is a concept that Git gives us to ask for less. We could use a shallow clone. That's a way of asking for less depth. Or we could enable large file support. Each of those techniques we'll discuss in a little more detail here to give you an orientation how any one of those four or all four together can help you reduce the load on your central repository. So a reference repository is a local copy of the remote repository, and Git can reference that existing repository rather than downloading the reference data. So imagine, if you will, a spot on your file system where you put a copy of your repository and everybody else on that computer points to it instead of downloading it again for themselves. Big benefit, it reduces network data transfer. Another benefit, it can reduce how much local storage you need on that machine that's using it. Be warned that reference copies are not automatically updated. So as your history grows, that reference copy, unless you're doing something special with it, doesn't keep up. The other is that because everyone creates pointers to it, if you destroy a reference repository, you have damaged all the references. So don't destroy reference repositories.
So
go ahead.
Let me just ask you there. So the reference repository is the underlying image. So if you have a bunch of jobs on that same client, they'll all use that local storage, that one copy, and then saving you space. That's how the space is saved, right? I'm sorry, Mark, you are actually muted because we're getting some echo, so you have to unmute yourself.
Got it. I see, you muted me, sorry. I'll turn down my speakers. So a reference repository is a local copy of the history. And so each of the jobs or each of the workspaces that are sitting on that disk can point to the history that's in that reference copy. With them pointing to that history, they get disk space savings from that. Did that answer your question?
Yes, that did.
Great, thanks. Okay, so in addition to a reference repository, you can narrow the breadth of the information that you request from that remote server. So what a Refspec is a Refspec is a Git way of saying, what are the things on the remote server that I want to bring to the local? And that Refspec, good online documentation, can tell you about how you can describe it, what the rules are that govern which things you can do in a Refspec and which you cannot. If, for example, you only need one branch in your build, a narrow Refspec can tell the remote server to only give you the history for exactly that one branch, where the default would give you the history for all branches. You can reduce local repository storage, you can reduce data transfer. However, there's a negative that because you asked for exactly that branch, if you are doing inside your job comparisons between one branch and another, if you didn't ask for the Refspec for that other branch, it won't be there. The other challenge is that Refspec patterns are limited. You can't use general purpose wildcards. You can put a wildcard on the very end right after a slash, but that's about it. There isn't any fractional pattern matching going on in a Refspec pattern. So Refspecs let you limit the breadth of your question to the remote server. Reference repositories let you avoid bringing down data that you've already got. The next way that you can help is you could ask, instead of limiting the breadth of the question, you can limit the depth of the history that you retrieve. So a shallow clone can limit how many entries in history you'll bring back from that remote server. So if your job really cares about building the current thing and does no operations with history, you can just ask for a shallow clone with depth 1. It will reduce your local storage, it will reduce the data transfer, and keep your job still running. However, there are downsides to shallow clone. For instance, you can't merge shallow clone work because it may skip changes in bringing them down to you. And so it doesn't have a perfect representation of the history. Change reports can be incomplete. So if you rely on reading the change log of a build, don't use shallow clone. The other is shallow clone is only available in command line Git. So if you're using JGit, you can't use shallow clone. So shallow clone gives us depth coverage. Narrow Refspecs control breadth. And then there's one more tool in your arsenal to reduce the load on your remote server. Some Git implementations have an extension which allow them to store large files outside the repository. That includes GitHub, that includes Bitbucket, includes Gitty. There are many that support Git LFS as a standard extension. It's a good way to do enterprise scale large file transport. LFS is high performance, it's very actively developed, and it dramatically reduces the requirement for local repository storage on you. However, there's a downside to it. You have to install the LFS extension on every agent that will run Git LFS. It does require extra support from the hosting provider, and at least in the earlier implementations, there's no support for SSH. It has to use HTTPS. The Git plugin itself also does not yet support submodules in LFS. And if you're working with the history of a large file, you may have to invoke separate LFS commands. Even saying all that, it can dramatically reduce the data transfer, because what LFS will do is it transfers the large files only for the current version instead of retaining the whole history of every large file inside the Git repository itself.
Now, Mark, when you say the Git repository, you're talking about your current one. The way that the large file support works is that it actually has another repository that it stores those in, right?
That's correct. Yeah, very good. You've understood it exactly. There's a separate area, if you will, on the remote server which hosts these large binary files. And that separate area is kept safe. It's kept backed up. GitHub's very good about it. Bitbucket, Gitty, all of them are taking very good care of your large files, but they're not stored right in the Git object store.
And effectively, behind the scenes, what's probably going on is some kind of shallow clone of those large files.
Yeah, that's a good way to think of it conceptually. Is give me the most recent copy.
Okay.
Great. So
continue. Go ahead. Sorry.
Okay. So now let's shift our focus away from helping your central server. What can we do to help the Jenkins master? Because there are things that will create load on the Jenkins master if you're dealing with these large files, these large Git repositories as well. So the master typically does pipeline scans of repositories. It also does polling and acts on notifications to check to see if there are changes in the remote repository, in the central repo. So each of those things may require a copy of the repository on the master. Therefore, if you've got large repositories, you can use reference repositories as described earlier, or you can use large file support, and they'll both actually help your master in addition to helping the remote. So two ways there, even with best practices in Jenkins where you generally don't execute anything on the master node, you can help it if you've got reference repositories dealing with these large files. Now on the agent is a place where you can get large benefit, significant benefit by using these techniques. So the agent is the one that's responsible to populate the workspace by checkout, and it's the one that builds the job. It does the work. So the key things that can help you there: narrow the Refspec so that you ask for less from the central repository and you get less stored on your local workspace. Use shallow clone to limit how much history you get when you don't need full history. Reference repositories can be a major savings on the agent. As Liam described earlier, if you have a repository which is used in hundreds of jobs, you can have those hundreds of jobs pointing their history towards a single copy on disk instead of having hundreds of copies of that exact same history. Large file support as well can be a big help for the agents because you don't carry around all of the history of all of your large binaries. There's one additional option that is agent specific, and that's Sparse Checkout. What Sparse Checkout provides you is a way to say which exact directories of this Git repository should I check out. Let's say that you've got a large tree of files in Git, in a single Git repository, and you want to limit that you're only working on a small subset of them under a subtree. You can use Sparse Checkout to check out exactly that subtree. Now, this doesn't help the remote. It doesn't help the master because this is purely an agent local operation to reduce work on the local agent. But it can help local agents in organizations where they have a broad tree, but each individual job only needs to work on a narrow part of that tree.